All right, so let's go back to the coin flip. Let x be the number of heads that are shown, and we already decided that this is what the values that we can take on. We can get 0 heads, we can get 1 head, 2 heads, or 3 heads, and that is definitely discrete. And so we're going to look at a discrete probability distribution. Okay. So what we need to do is we need to find the probability of each of these events happening. So what's the probability of rolling 0 heads, or flipping 0 heads when we flip 3 coins simultaneously? So 0 heads is only 1 out of the 8. There it is. There's 3 tails. Okay. So this is 1 out of 8. 1 head showing. Okay. Well, there's 1 here. There's 1 here. There's 1 here. So there's 3 of those. So this would be 3 out of 8. We already established that there's 3 out of 8 ways to get 2 heads. And then there's 1 out of 8 ways to get all 3 heads, and that's all 3 are heads. So this is what the probability distribution looks like. This is the random variable, and this is the probability that each random variable is going to take place. Now what you notice is that all of these probabilities are between 0 and 1, because that's how probabilities work. And if we sum up all of these probabilities, we end up with 1. So those are the requirements for the probability distribution of a discrete random variable. X is all the probabilities, P of x, have to be between 0 and 1, and all of the probabilities have to sum up to be 1. We can also look at this graphically. If you remember how to do a graph, this looks just like a sort of a grouped data situation. And so we can go to Insert, we can go to Scatter Plot, we create the scatter plot first, then we change it to a column graph, and we make sure that the bars are touching. I'm going to put 1% in between. And so this is my probability distribution. We can see it both as a table and as a graph. And along the x-axis, we would want to put a label, and this would be, if we go to our chart design, I'm going to add axes labels. And over here, this is the relative frequency, or the proportion. And along here, this is the number of heads. And our title should be something like the number of heads that show up with 3 rolls, or 3 flips. Three coins. There we go. All right. So we have our table, we have our graph, we have our requirements. So now let's use these requirements in a new problem. So now we have a loaded die. It's a loaded die, so one roll comes up half of the time, and the rest of the rolls are equally likely. If x is the count on the die, find the probability distribution. So we're always going to have an f and a p of x. In this case, if I roll a die, the possible outcomes, the count would be 1, 2, 3, 4, 5, or 6. Now the probability of all of those is usually equally likely, but it's saying that the probability that I roll a 1 is actually going to be 50%. Now remember, we said that the sum of all the rolls, the sum of all of this has to add up to be 1. So that means that these remaining 1, 2, 3, 4, 5 rolls or counts need to add up to 1, but they all need to be the same number. So what we can do is we can take 1 and subtract the probability that we already know is happening, and then we can divide by 5. And that gives us 0.1. So that means that each of these is 0.1. And you can see at the end, once I add all of those together, I end up with 1. So that is our probability distribution. We're going to do this one more time with another example. Now we have another loaded die. But this time it says a 4 occurs 72.43% of the time. And the rest of the rolls are equally likely. So again, X is the count on the die. So that's going to be 1, 2, 3, 4, 5, and 6. Those are the possibilities. And we know that a 4 occurs 0.7243. Remember, our probabilities have to be between 0 and 1, so we can't write it as a percent. We have to write it as a decimal. So I'm going to go through the same calculation again, and I'm going to make sure that my sum is ready to add up all of these. So my calculation is going to be 1 minus this value, and I'm going to divide that by 5. And that gives me 0.05514. I'm going to put 0.05514 right here. And that same value I'm going to copy here and then copy here. And you can see when all of these are filled in, my probabilities sum up to 1. All right, I'll see you in the next video where we will find the mean and the standard deviation of our probability distribution and talk about what that means.